Today's lesson is going to talk about two kinds of transformations. We're going to talk about vertical translations and horizontal translations. In my opinion, I think these are the easiest transformations that we'll do. So it shouldn't be too terribly difficult. So let's just start with a basic parabola. If you remember, you'll have the point 0, 0, 1, 1, and 2, 4. So I know that this is going to basically be reflected over here, so I'll just copy this. Alright, so that's basically your basic x squared function, a quadratic parent graph. So what we're going to do now is we're going to take the original function and we're going to increase it by 3. So if you think what that actually means, that means you take your original parabola and you're going to actually take all those outcomes and you're going to add 3 to them. So before, when you plugged in 0, you got 0. Well, if you add 3 to that, now when you plug in 0, you get 3. And before, when you plugged 1 in, you got 1 as your height, but now you're supposed to add 3 to that, and now your height's going to be 4. Same thing with 2. When we plugged 2 in, we got 4, but now if we plug 2 in, we're going to get 7. So it's going to be somewhere up here. And then I can actually just reflect that over here as well. So you need to think of it as if you were making an XY table. And whatever you would have got beforehand, now you're just going to add 3 to the previous. So before, again, you would have got 0. If you add 3 to that, you get 3. Before, if you plugged in 1, well, 1 squared is just 1. If I add 3 to that, I get 4. And 2 squared is 4, but if I add 3 to it, I get 7. So really what we just did with this is we kind of just did the table in our head. We're just adding 3 to wherever the number previously was in regards to height. Right, so let's take that same mentality and let's try to use that down here. Now it does say to use red for the parent function, so it wants us to graph a basic parabola, so I'm going to do that with red. Try to do it as neat as I can here. And then we're going to use the transformation as blue. So basically, wherever my red dots were, they're all going to be lowered by 3. So 1, 2, 3, 1, 2, 3, and 1, 2, 3. And then I'll just reflect that over here. So there's your transformation. All right. It doesn't change with a square root. So if you graph a basic square root problem, parent function, right? 0, 0 is an ordered pair, 1, 1, and then we can do the square root of 4, and that gets us 2. So I usually use those 3 points to guide me. You want to take the same mentality. So all your previous answers in terms of height are going to be lowered by 5. So this point 0, 0 is going to drop to 0, negative 5. This point, that's 1 high, will drop to negative 4 high. And this point, it's 2 in terms of the y-axis. So if you lower that by 5, 1, 2, 3, 4, 5, you'll be at negative 3. Oops, and I guess we should be using blue for this. Again, if you're never sure, you can always make a table, but this is going to save you time if you just think that everything's dropping by 5. Basic absolute value, so we have 0, 0, 1, 1, 2, 2, etc. It basically reflects this way. Okay. So basically you still have your original absolute value function, but everything is going up a unit. So you're basically adding 1 to your answer. So instead of 0, 0, we're going to have 0, 1. Instead of 1, 1, it's going to be 1, 2, and etc. And then last but not least, we have the basic reciprocal function. So remember that that means you have these imaginary lines. And then your curves will basically get closer and closer to those dashed lines as time goes on. Oops. Here we go. Right. So this one's going to be a little bit trickier because there's not really like a starting point for these. Like these guys all had like a starting point. You could just drop points down. So instead, what I want you to think of, instead of trying to move these curves, we're going to move our dashed lines here. Our asymptotes is what they're called. So when we're talking in terms of height, you need to think, okay, which line here, the vertical or the horizontal, deals with height? It's always going to be horizontal. So we want our horizontal line to be 3 units high. So my new parent function would still have a vertical line through 0, but the height now has grown by 3 everywhere. And I would need to reposition these curves in between the red imaginary lines. So now my curves will basically shift up 3 units, but that's how I'm going to show that, is by shifting that horizontal dashed line up 3 units. This is where I'm going to pause the video, and in my next video I'll talk about the horizontal translations.